Welcome to Stephen's Academic Tuition Center. This is the lesson in physics under force. So the first stage we need to know and understand the meaning of the word for force. So first I will start by defining the word force. So when we talk about force, so force is a pull or push acting on an object. So if one can say force is a pull or push exerted on an object. So talk about pull. There's push and pull. So pull, you put down side, pulling toward yourself. Then push is pushing something away from yourself. So mkapiza don yole me what pull, which means you could dance and pushing. That's a simple way. So which means force is a pull or push acting on an object. Then we need to know that the SI unit of force is Newton, which means when they ask you to calculate or find force, the answer always need to be in Newton. Then apart from that, the force is a vector quantity. So vector quantity is a quantity that has got both magnitude and direction. So magnitude is same as the size. So vector quantity is a quantity which has got both magnitude, which is size, and direction. So force is a vector quantity. Then we've got some examples of forces. So the first example is weight. Weight is also part of force. So when they ask you to find the force, which means they have also asked you to find the weight. So weight and force, they're just same. Apart from that was also friction. So friction, we call it a friction force. So friction is also part of the force that oppose the motion of two touching surfaces. Apart from that, we have the electric force. So we have electric force. All these are examples of forces. Also have the magnetic force. For example, like when you get a magnet, you get a north pole and north pole. You try to push them closer. There's that force that you cannot even see. So we call it a magnetic force. So now, I'll start with defining friction. As I said, that the friction is a force that opposes the motion of two touching. Motion means movement. So the force that opposes the motion of two touching surfaces, we call it friction. For example, moto akudakumanga tuma brake sai kunjinga kumanga ma brake. Example in tire. This is a tire. Then there's the kumanga brake. So example ukagwira brake pezikati there's a friction between the tire and the brake pad like this here, which means we call it a friction force. So a friction force is the force that opposes the motion of two touching surfaces. Okay, that's a simple definition I can give you. Then examples of contact force, we have a friction. Then so friction is a contact force because as I'm saying that a friction is a force that opposes the motion of two touching surface. And for something to be opposed, which means the surfaces are in contact. So the friction is an example of a contact force. Then an example of a non-contact force, also have the gravitational force, also have the magnetism. So gravitational force is the force that pushes something toward the earth. Then also I've got magnetism. Then and forces between the electric charges, all those we call them non-contact forces. Then what are the effects of forces? For example, like when a force is being applied on an object, what are the effects of force? So the following are the effects of forces on an object. Number one, the first point is force can change the size or shape of an object, which is true. For example, as you can see, this is the phone pouch. Then when I try to apply a force here, as you can see, the shape is being changed. Because I'm applying a force here. So the shape is being changed. So a force can change the size or shape of an object. Apart from that, note that the force cannot change the mass of an object. So even if you squeeze something, you push it, but the mass will remain the same. Even if the object changes the shape, but the mass always remain the same. So in short, we're saying that the force can change the size or shape of an object, but it cannot change the mass of an object. So be careful on that point. Okay, so force can change the motion of an object, which is true. For example, if a car is parked and if you try to push it, which means you have changed the motion of that object. Apart from that, force can change the state of rest of an object, which is true. As I said, when a force is being applied on something or on an object which is at rest position, which means that object is able to move. So the force can change the state of rest object. Then go to the inertia now. So what's inertia? So inertia is a property of matter that causes it to resist any change in its motion. For example, munanga motoka makwera motoka mshimushi, then manje driver but emergency brake. What happens? We all tend to move forward. Start what moving forward. What causes that? Because of inertia. Because we are trying to resist that change. So inertia is a property of matter that causes it to resist any change in its motion. Then the larger the mass, the smaller the acceleration, which is true. So example, like you can't compare the speed that track and speed yakamotoka ngono like Benz. Although Benz it is by mataba, but track chikuru chimataba na but you can't compare the speed. So the larger the mass, the smaller the acceleration. Then again, the more the mass, the more the inertia. For example, like track tamangira per 100 na Benz tamangira per 100. Then tikacha emergency brake, which vehicle have more impact, Benz or truck? So the truck, since it is heavy, it has got more mass, so it means a truck, it will have more impact, it will have more inertia compared to the Benz. Okay, so the more the mass, the more the inertia. Then the less the mass, the less the inertia. So you can see we have the wire car, it has got a low inertia, while the truck here, it has got a big or high inertia here. Okay. Then we go to the Newton's first law of motion. We equate the law of inertia. So we need to understand almost the three laws, the Newton's 3 laws of motion. The first law is talking about inertia. So Newton's first law of motion states that a body continues to stay at rest in uniform velocity in a straight line unless a force acts on it. So this law simply means that the object will continue being at rest if it is at rest, and if it's moving, it will continue moving at a constant speed in a straight line. So for example, provided there's no force that's being applied on it. So for example, like if a car is parked, provided there's no force which is being applied on that car, the car will continue being at rest position. But if the car is moving and there's no friction force, there's no any force that's being applied on that car, the car will continue moving in a straight line. That's all about the Newton's first law of motion. So it's talking about the inertia and the force. So for example, like when a body is at rest, provided there's no any force that's being applied, that car will continue being at rest. And if it's moving, provided there's no a friction force, there's no any force that's being applied on that object, surely the car will continue moving in a straight line. Okay. Then we go to the resultant force or net force. So resultant force is simple definition. I'll say that this is a force. This is when two or more forces acts on an object. So the resultant force or net force, these are forces that two or more forces that acts on an object. So according to the definition here, they're saying that is the combined effect of all the forces that act on the body. But as I said, a simple term can say this is when two or more forces acts on an object, we equate the resultant force. So for example, as you can see, we have the force 8 Newton going on the right hand side and 5 Newton on the left hand side. So if the forces are going in different direction, so for us to find the net force, we need to subtract. Hope it's very much clear here. So for us here to find the resultant force, we need to subtract, which is 8. So you say 8 minus 5. So the answer will be 3 Newton. This is how we find the resultant force for question 1. Question 2 again, as you can see, we have two forces going in the same direction and one force, which is 11 Newton, going on the left-hand side. So for us to find the resultant force, we need to do what? To subtract, which is this 11 minus. So we need to add these two, which is 4 plus 5. So 11 minus, so we add 4 plus 5, which is 9. The 9, so 11 minus 9, which is equal to 2 Newton. So this force, the resultant force here, we have 2 newtons. And the question 3, we have two forces, 3 newtons and 2 newtons going on the right hand side, and two forces also, 1 Newton and 4 Newton going on the left hand side. Since the two forces here are going in the same direction, so you need to add. So you add 1 plus 4, which is 5 Newton, and also 3 plus 2, which is also 5 Newton. So for us to find the net force, we need to subtract a 5 minus 5. So it's a 5 minus 5. The answer is what? Is 0 Newton. So the resultant force is 0 Newton here, which means this object, it won't move to any direction. It will just be at its rest position, because the 5 Newton this side, 5 Newton this side. So we have net force is equal to 0. This object will not go to the right, no, to the left hand side. It will just be at a fixed position. Okay, so now we go to if the forces balance each other, the net force on the body is 0. For example, like example number 3 here. Okay, so this is the exercise. You can try to answer it in time, and you can submit the answers for marking. Question A is saying, explain the term inertia. So I've already explained what inertia is. Question 2, name the quantity that is measure of inertia. So the quantity that is a measure of inertia, as I said, is mass, or anyway, it's exercise. So you can try to answer it. The question 3, state Newton's first law of motion. I've explained this one very well. Then question 4, you are standing in a bus. Explain why you hold on tight when it starts to move. Okay, that's the question there. I know that some people would just example like they're on the bus, then they try to hold tight to certain objects so that they don't fall. Why? Okay, describe and explain what happens, to the passengers in a bus if it stops suddenly. So this is also a part of exercise. So you can try to answer this question and also submit answers for marking. Then Newton's second law of motion. So Newton's second law of motion is talking about the issue of the connection between the acceleration, force, and mass. So it states that a force acting on a body produces an acceleration in the direction of the force. So Newton's second law of motion states that a force acting on a body produces acceleration in the direction of the force. Then this acceleration is directly proportional to the force and inversely proportional to the mass. So in short, we're saying that acceleration is equal to force over mass. So which means this can be, a simple term can be written as a force is equal to mass times acceleration. So the formula for force now, we're saying that force is equal to mass times acceleration. This force must be Newton and mass in kg. So pay attention that if the mass is given in grams, you need to convert that grams into kg, and acceleration Newton per kg or meters per second squared. So this is a formula for force. So force is equal to mass times acceleration, and you need to know this formula very well. So I've got an example here. A force of 350 acts on an object of mass 10 kg. So I have a force here and a mass here. Find the acceleration. So as I said, a force is equal to mass times acceleration. So the force is given in the question, which is a 350 Newton. So why there's a force, we are going to put a 350 Newton here. 350 Newton. Then is equal to the mass is 10 kg. Acceleration, we don't know acceleration here. So I'm trying to find acceleration. So we can say over 10, and here over 10. So that we can cancel this. So acceleration is equal to this and this cancel. So if you want here, you can use the calculator. You can say 350 divided by 10. So the answer is 35 meters per second squared. This would be our final answer for that question. That will be our acceleration. Okay. So question 2, we have what is its acceleration? Okay, no, this is a different question. Okay, but question 2, a man pushes an 8 kg luggage. So this 8 kg luggage, as you can see, this man is pushing it. Then on the smooth floor, it starts from rest, which means our initial velocity is 0. So initial velocity is equal to 0 because it started from rest and reaches 15 meters per second in 5 seconds. So the initial velocity is 0, the final velocity is 15 meters per second, and the time taken is what? Is 5 seconds. So now, what is its acceleration? So for us to find acceleration, we can use this formula. We can say acceleration is equal to v minus u over time. This question A now. Question A. Okay. So now we are finding acceleration, and the acceleration is equal to the final velocity is 15. So I'm going to write 15 here minus initial velocity is 0 since it started from the rest, which is 0, and the time taken given the question is 5 here. So I'm going to put 5 here. Then I will say acceleration is equal to 15 minus 0, which is 15, over time, which is 5. So acceleration is equal to 5 into 15, which is 3. So I have 3 meters per second squared. That will be our acceleration there. Okay, so now we'll go to question B. Question B, I will do it from this end. Question B is saying that what is the acting force on the luggage? So they wanted to find the force. As I said, we're saying that force is equal to mass times acceleration. Then we're looking for force here. We're looking for they say that find the force. So we're saying that force is equal to mass given for the luggage is 8 kg. So I'm going to put 8 kg here. Then times acceleration, the one that we have calculated here on part A, which is 3. So put 3 here. So force is equal to, so 8 times 3 is 24 Newton. Don't forget the SI unit for force is Newton. So this is the answer for this question. Okay, so I'll go to the next part. This seems to be an exercise, okay, of exercise here. So the figure below shows an object of mass 0.7 kg resting on a horizontal surface. Okay, so as you can see, we have this object, the force going on the left hand side is 6 Newton, and on the right hand side is 2.5 Newtons. So for us to find the force, the resultant force, we need to subtract, because the forces are going in different directions. So we subtract this minus this, okay, which is almost 3.5, somewhere there. Okay, so if the object is pulled to the left by force of 6 Newton and to the right by force of 2.5 Newtons, and assuming that no other forces act on the object, calculate. The first one is the resultant force. So as I said, the resultant force, you need to subtract 6 minus 2.5. So you can do that and write the answers as a part of exercise. Question A2, I mean, the acceleration produced by the force. Okay, by the force in this one. So this one, okay, we can use this formula. Where you say force equal to mass times acceleration. The force, the one that we have calculated here, we're going to put it here. Then the mass of this object, the result acceleration, okay, find the acceleration. So the mass given the question, which is 0.7 kg. So put mass here and acceleration we don't know. So from there you find acceleration. Then the question B, explain why in practice the actual acceleration for the object may be lower than your answer in. Okay, so this one you can search more, but what I can explain that this is due to the friction force between the object and the surface. Okay, so now we go to friction, the friction part here. So we go to the friction. So as I said, friction, the force that opposes the motion of two touching surfaces. So apart from that, we know that friction acts in the opposite direction of the motion. The larger the friction exists between rough surface. So in short, the larger friction exists or take place between the rougher surfaces. Okay, if the surface are smooth, which means there'll be in fact there'll be less friction. But if the surface is rough, which means there'll be more friction. Okay, so for example, if you push a luggage, friction is caused between the luggage and the floor. Its direction is opposite to pushing force. So if the object going this direction, the friction force goes to the opposite direction like this. So this is how you're supposed to understand this part here. Then we go to what are the application of friction. So friction is very important in our daily life. The first one is we can walk without slipping. Yes, so we walk because of friction force. A vehicle car can move and stop because of friction. Yeah, we can hold, as you can see, there's a friction here between my hand and the pen here. There's a friction here, so we can grip or hold something, e.g., a pen in our hands. Okay, nails hold something tight. It's also part of friction, but the same friction again. It has got what to cause some consequences. So, friction cause energy lost and reduce the efficiency of a machine. Yeah, which is correct. Yeah. So these are the effect of or consequences of friction. Then it also causes rapid wear and tear. So how can you reduce friction? So friction can be reduced uh, by adding lubricant such as oil, grease to the machine. So in case if they ask you how can you reduce friction, so friction can be reduced by by applying or add lubricant such as oil, grease to a machine. Then the next part is a motion in a circular path. Motion in the circular path, which means motion in the circle. Yeah. So, for example, we have this outdoor. This is a circle. So this is center. Then we have a force, which is this is circular motion. The force that goes away outside and the force that goes inside like this. So the force that moves toward the center of the circle equality centripetal force. Then the force that move away from the center is called centrifugal. Centrifugal. Yeah, so we have a centripetal force, the force that pushes an object toward the center. The centrifugal force is the force that pushes an object away from the center. So centrifugal away from the center, centripetal toward the center. So I have two forces here under circular motion. The force that pushes an object toward the center is called centripetal force, and the force that pushes an object away from the center is called the centrifugal force. Okay. So, for example, as you can see, we have a car. A car is moving maybe toward the cave. So, the force that pushes this object away from the center, away from the cave, is called centrifugal force. Then the one that pushes this toward the center or toward the cave is called centripetal force. We go to the crucial part, which is the effect of force on a spring. So, example, like if I have a spring, what happens when you apply a force on the spring? So I have an experiment here, an explanation on the experiment here. So we have the aim of this experiment is to demonstrate the relationship between the force applied to a spring and its extension. Okay, the following are the materials that are needed. The first one is a spring or spring balance, just a spring or spring balance. Number two, have a mass pieces. We need to have different masses, a ruler. So I have a procedure here. The first one is measure the length of a spring, original length. So before you, example, this is a spring. Before you put an object here, you need to measure the length of the spring using a rule. Okay. Then from there you calculate the weight of each mass pieces. So you need to know the mass or the weight of each mass is given. Then number three, you suspend different mass piece from the spring. So for example, like before you hang any mass here, you try to measure the length of the spring. as the original length. Then you get the first mass, you place it here, which means the string is going to extend. Example, like is that for a spring? Then you record. Then from there you can, if you want to know the extension, you subtract the length of the spring when the mass was placed from the, you subtract with the mass, you subtract with the original length of the spring. For example, like maybe before putting anything, example, this is a spring, it's a spring. Before putting anything, maybe it was at 2 centimeters, okay, like this. But after maybe putting this mass, maybe after measuring the distance from here to here, the distance will increase maybe from 2 maybe to 5. So it means our extension, first find the extension, subtract a 5 minus 2. The extension will be what? Will be 3 centimeters. This is what I mean on this point. Okay, as you can see, we have a ruler here to measure. So, for example, like when you put your object here, the spring will extend. Then you get the reading. You get the reading, just like the way it's showing here. Okay. So now, the measure and record how much each mass piece extends the spring in table. So, for example, like when 0 Newton was, because before you place anything here, the length of the spring maybe it was 10.5 centimeters, which means there was no extension. The extension was 0. Okay. Then again, here there's at the end here there's extension over load, which means you divide the extension divide by load. Okay. Then again, when you put 1 Newton here, the spring will move from 10.5 to 12.5, which means our extension will be what? You subtract this minus the original, so it will be 2 centimeters. Okay. Then again, when you put 2 Newton here, which means again our extension, our length of the meter of the spring will increase from 10 to 15. So for us to find the extension, subtract this minus this. So in short, we're just subtracting if this number minus the original length of the spring, and also this number minus the original of the spring, everything minus the original length of the spring to find the extension. Okay, hope it's very much clear here. Okay, so now from there we can see that extension is equal to the length of the extended spring minus the original length. So don't forget that extension is equal to the length of an extended spring minus the original length. So this is a formula that we can able to use when finding the extension. So extension ikaja, so ifungo cha minus length of an extended spring minus the original, which is 10.5. So we are subtracting all these numbers from this 10 so that we can find the extension. Okay, then from there you can able to draw the graph of the result. So as you can see here we have here we have the extension against load. So you can plot a graph of load extension against load. So when they say extension against load, the extension need to be on the vertical axis and the load on the x-axis, which is the horizontal axis. When they say step freeze against joint, so you put step freeze here, joint here. When they say pen against pencil, so pen here, pencil here. This is how you are supposed to do it. Then from there you can come up with a conclusion. Okay. So I know before the end of this topic, I'll come up with a question and how to do the graphic on this topic. Okay. Then Hooke's law. So this law is very important, and they like asking it. In fact, maybe for example, like state Hooke's law, so you need to understand what a Hooke's law is, and also are able to apply the formula for the Hooke's law. Okay. So we are saying that Hooke's law states that the extension of the loaded spring, pay attention on this one, the extension of the loaded spring is direct proportional to the load, provided the exceeding limit is not reached. The extension, this states that the extension of the loaded spring is direct proportional to the load provided the exceeding limit is not reached. So what we mean here, example, this is a spring. This is spring. So when you put a mass here, the spring will extend. So provided simafake viforce vambiri so that yankala so pa spring yankala straight spring. Spring example ya mkafaka masi yole ma spring abankache straight, so nishmaono ngapa nishi yache exceed manje chani yache exceed manje limit, so nishmanje yale konkala oxro. So oxro ikambati the extension of a material is directly proportional to the force that is exceeding it. That's the concept for the Hooke's law. So this Hooke's law, you need to know it, and the limit at which the spring is stretched is called the elastic limit or limit of elasticity. So pay attention to these things. Apart from that, we're saying that extension is dead proportional to the force, provided the extension limit is not reached. So from there, we can say constant, which is K constant, is equal to extension over force. So this is like a formula on extension. So K constant is equal to extension over force. If one can say extension is equal to K times 4 times force, like this. This is like a formula to use now. So K stands for constant, E extension, F for force. So again, here we have the Hooke's law gives the relationship between the force applied on an unstretched spring and the amount the spring is stretched. So as you can see, we have the equilibrium length here, the straight length here. Okay, so this is the point here. So now I have some questions where we're supposed to use this formula here. So they're saying that a load of 4 newtons extended a spring by this. Okay, what load would extended it by 15 millimeters? So for us to find the answer, first we need to find the constant. So now how do you find the constant? So you need to come up with the formula here, where I will say number 1 here, I will say constant is equal to extension over load. Good. So we're looking for K. So K is equal to, what's our extension? So a load of 4 Newton extend a spring by this one. Okay, sorry. So now we're saying that a load of 4 Newtons extend a spring by, so it means the load here, the force, the load here we have what, which is the force, we have 4 Newtons. So we're going to put 4 Newton here. It extends the spring by, so extension of 10 here. So it means we can say constant is equal to, so we can say we can divide here, we can say 10 divided by 4. The answer is 2.5. So the answer constant is 2.5, which means if you want, you can put this one in 2 fraction, which is 2 here, or if one can say K is equal to, you can say 2 here is 5. 2 here is what is 2. So this one can be also be a constant. Now they're saying that what load would, so again you can say K is equal to extension over load. So a constant here is 5 over 2, which is same as 2.5. So it means I will use the fraction, which is 5 over 2, then is equal to our extension. So what load? So the want load, our extension is 15 here. So put 15 here, then over what? The load we're looking for, which is going to put L here. Okay, you can put L here. Then from here, of course, multiply. So 5 times L, it will be 5. L is equal to 2 times 15, which is 30. Then over 5 here. Then you cancel. So L is equal to 5 into this one to be 6 Newton. So which means our load is 6 Newton. So this is how you find this one. So first stage, you need to find the constant K by using the formula. Constant is equal to extension over load. Then from here now, you find k. After finding k, you write the same formula. While there's k, since k is constant, so you substitute with this value given. Then now, after substituting, you solve now the what's needed in the equation by making the substitution. Then you come up with the answer, which is 6 Newton. 6 Newton. Then I also go to question 2. Question 2. Question 2 here. Okay. Question 2 is saying that, I'll read the question carefully. Question 2 is saying that, calculate the extension of a spring that would be produced by 20 Newton load if 15 Newton load extend the spring by this. So again, to find the k. So as I said, k is equal to extension over load. So k, we're looking for k first. K is equal to our extension here. Our extension is 3 centimeters, so 3 here over load is 15 newtons here. Okay, so you can say k is equal to, so if you want, you can leave this one in two fraction form. So 3 here it's 1, 3 here it's 5. So to be k is equal to 1 over 5. So now for me to find what they required to, so we can say a k is equal to E over load. Okay, so my extension, my k first, my k is 1 over 5. Extension, so calculate the extension. So extension is, I'll put E here. Load, calculate the extension of a spring that would be produced by 20 newtons. So I'll put 20 here, like this. So now I'll solve, I'll cross multiply. 5 times E, it will be 5E. E is equal to 20 over 5 over 5. So I'll say extension is equal to 5 into 20, it is 4. So 4 centimeters. This will be my extension. Okay. That will be my extension for this question 2 here. In fact, it's for this one, yeah. Then this one, I'll leave it as your homework assignment. This is question 1. So what I've solved, you have solved this one and this one. This one will be your task now. Okay. Then I have a question on the graph. So a spring with its upper and end fixed hangs vertically alongside a meter rule. The lower end of the spring gave the following reading in the table below when various masses were hung from it. So this is the question. I'll start with question. This is question 3 from the previous exercise there. So this is a question, and it's coming from certain past paper. Is the final exam. Okay, in fact, this one will be your exercise as well. So we can do this one, question 1, 2, 3, and question 4, which is here. Question 4, which is here, you can do it as well. So we can be your exercise. Thank you very much.